Hey guys, let's talk about the sine function. Not this sine function, this sine function. It's a function that returns the sign of your number, and it can be defined like this. If x is less than 0, or in other words, if x is negative, it returns -1. If x is 0, it's 0. And if x is greater than 0, or in other words, if x is positive, it returns 1. And here's the graph of it right here. For all the places where x is negative, its value is -1. At 0, it's 0. And then all the places where the x is positive, it's equal to +1. So for example, the sine of 3, we look at 3, it brings us up to 1, the answer is 1. Sine of -3 is right here, it goes down to -1. Sine of any negative number will be -1, and sine of any positive number will be +1. And sine of 0 is equal to 0. Oddly enough, the sine of 0 is also 0. I wonder if they have anything else in common. Sine of pi over 2 is equal to 1, and sine of pi over 2 is equal to 1 because pi over 2 is positive. That's kind of cool. And also over here, sine of negative pi over 2 is equal to -1, but sine of negative pi over 2 is also equal to -1 because it's a negative number. And we can have a little bit more fun with this. The sine function hits the x-axis at both negative pi and positive pi, so we can say sine of negative pi is equal to sine of pi, but sine of negative pi does not equal sine of pi. Another cool thing about this sine function is that any real number can be expressed as the absolute value of it times the sine of it. So -3 is equal to the absolute value of -3 sine of -3. And we can verify that the absolute value of -3 is +3, sine of -3 is -1, and that all equals -3. We can also do it for 3. Absolute value of 3 is +3, sine of 3 is +1, that all equals 3. And this is true for any real number, even 0. So we can put a box around this. If we divide both sides by sine, we get this equation here, where x over sine of x equals absolute value of x. And oddly enough, these two are also true. As long as you got an x on one side and an absolute value of x on the other, you can put your sign anywhere in the equation and it will be a true statement. This kind of stuff does not happen very often. That's pretty cool. And there's even more interesting stuff. If we look at the absolute value of x, it makes a giant V. And if we look at the slope of each side of this V, slope is rise over run. So on the right-hand side, it rises 1 and it runs 1. So we have a slope of 1. And on the left-hand side, since it goes down 1, it rises -1 and it runs 1. And that's equal to -1. So everywhere where the slope of the absolute value is equal to 1, the sine function is also equal to 1. And everywhere where the slope of the absolute value is equal to -1, the sine function is also equal to -1. So for any time when x doesn't equal 0, the slope of the absolute value of x is the sine of x. And for those of you taking calculus, your teacher probably taught you that the derivative of absolute value of x is equal to x over absolute value of x. And this is correct, they are right. But you could also tell them that for x not equal to 0, that the derivative of the absolute value of x is equal to the sine of x. And the teacher might tell you you're wrong until you explain to them that if you're using this sine function and not the trig sine function. And here's the intro to the sine function you've probably never heard of. How exciting.